Well, a warm welcome, everybody. Thank you for being here. Go ahead and get yourself ready with a notebook, a pencil, or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you out of nowhere. And today we have a problem in calculus regarding particle motion. It might also be called rectilinear motion in some classes. Yes, but mostly we're going to get a chance to use Desmos and see how Desmos works to help you out with the AP Calculus exam. Go ahead and take a good look at the situation. There's an equation that's given for us to give us the velocity. And then take a look at the three parts here. We have parts A, B, and C. This is not my own problem. I don't want to take credit for it, but it is a good problem. Okay, give yourself about, 10 to 15 minutes. If you can do this problem in 6 or 7 minutes, it means you're really familiar with both the calculus and how to use Desmos best. If you're a little less familiar with one of those things, calculus or Desmos, it might take you closer to 10 minutes, maybe 10 to 12. And if you take 15 minutes, hopefully that's as long as it takes as a maximum. Otherwise, you're lacking in both areas for sure. Okay. So after you've given yourself some time to try it for yourself, you could also just use a TI calculator. That is fine. It's a little harder to use it, but you could. Then when you're ready, unpause the video, join back, and see how we did it here. Okay, let's get started. So first glance at the problem, we have the velocity, which is given, of the particle. And we have this funky power, -2 plus the quantity t squared plus 3t to the 6/5 power. Very interesting. Minus t cubed. And it's only over this interval from 0 to 5. They're also given this initial condition about the position of the particle. We'll see if that's important at all. Possibly not. Okay, part A wants us to find all values of t on this specific interval from 2 to 4 only, for which the speed of the particle is 2. So this allows us to break down a couple of interesting concepts that are important for this type of problem. The concept of speed. Speed is not your velocity, because your velocity includes a negative or positive depending on the direction. Speed does not care about the positive or negative value. So we can think of speed as the absolute value of the velocity. And if we want to know when this is equal to 2, here is another very useful tip in just mathematics, really, but especially in calculus, and especially when you're using graphing software. If you want to know when two things are equal, the easiest way to express that two things are equal, in my opinion, is not actually by putting one on the other side of the equal sign. What? I know. It seems crazy. Hear me out. The best way to tell when two things are equal is when their difference is 0. Minus means like a difference, right? So if there's no difference between these two things, meaning when you subtract them you get 0, then they are equal. And why do I want to think of it like that? Well, if I think about it like that, I can just take the expression for v of t, put it in an absolute value, and subtract it from 2. And instead of having to, not that this is a huge deal, but let me show you what I mean. If I have that y equals, I'm just going to use y and x, there's no real difference. -2 plus x squared plus 3x, and that was raised to the 6/5 power, minus x cubed. Now, if I want to find when this equals to 2 or -2, it's kind of a pain in the butt. I mean, it's not the worst thing in the world. I can say that it's pretty much right there, and it's pretty much right there. And if I wanted to graph y equals 2, and y equals -2 on the same graph, I could just point out these values, right? So why don't you go ahead and take a look at those values and really think about those values. Which ones are even considered here? We have this one here. So these are all the points where the entire graph crosses, right? But we have a restricted interval. We're looking from 2 to 4 only. So now I have to kind of just look between 2 and 4, and it's a little bit messy, right? Because this thing's bouncing around the whole time. So instead of doing that, here's what we're going to graph. We're going to graph the absolute value of this function, and then we're going to subtract 2, and we're just going to see when it crosses 0, which is way easier to look at because we have this big bold line called the x-axis, and then we can just zoom in from 2 to 4, and we don't have to worry about, oh, well, I have to look up here at 2 and look at the y values at 2. You don't have to worry about any of that. You see what I mean? I get a little momentum when I'm talking about this thing because this is just like a really great, simple way to find your values. Those are the two values of time. So we would take those, let's see, let's maybe copy paste. There we go. Oh, that's a little weird. Let's make it t equals that value. How about that? And the next one would be t equals, and let's just copy the actual time there. There we go. Yeah, no need to complicate it. So do you see how quick and easy that is, really? If you know what it is that you're looking for, the speed, which is the absolute value of velocity, and it's equal to 2, which means there's no difference between it and 2, then you can simply look at the graph, find when it crosses 0, instead of looking for when it crosses 2 or -2 or some other values, just simple x-axis, and you're good to go. Now, they wouldn't ask you to justify the reason there, because you just have to look at the graph, literally. Okay, let's move on to part B. Find all times t, suggesting there's more than one. And this interval is from 0 to 5 now, so that's the full interval that we were told about in the beginning of the problem. This only exists from 0 to 5, at which the particle changes direction. And this time we do have to justify our answer. So let's take a moment to use our calculus analysis again. Change direction. What does that mean? That doesn't just mean the velocity equals 0. I know a lot of you think that, oh, it's just when the velocity is 0. That's not correct. It's more specific than that. We're saying that the particle changes direction. So we're looking for when v of t either goes, it changes sign. So it either goes from negative to positive or positive to negative. And that's really easy to find because now we can just look at the velocity function itself. Now we don't want the absolute value. We want the actual graph. Oh, there we go. Yeah, I guess I got to zoom out a little bit. And we're only looking from 0 to 5. So on the x-axis, see how I have it cut off here at 0 and then pretty much cut off here at 5. I'm just looking for when it changes direction, not just when it hits the curve. Fortunately, we don't have any of these spots where it like bounces off the x-axis. That would not represent a change in direction. And again, this graph is the velocity. So if the velocity is going from negative to positive, this is on the negative side, and now it switches over to the positive side. Well, then it changed direction. That means I was going backwards, then I started going forwards, so I had to change direction. And then over here, the velocity is positively valued, hits the 0, and then it goes negative, which means now it's going backwards. Again, that's a change in direction. Oops. Scrolling is actually the most difficult part on Desmos. It's not that intuitive. You have to click scroll, because if I try to like 2-finger swipe, it just zooms in and out. Okay, anyways. So we're going to copy this, And again, you see how quick and easy this is if you know what you're looking for. So that's why I want to show you how to interpret the calculus part of it, and then show you the simple tricks and methods that I use on Desmos, so that you're not, graphing 3-4 different things. And always always consider clearing your graphs when you're done. It's kind of like a chef after they cook something, prepare something. Always wipe down your area. So we have t equals that, because velocity goes from positive to negative. You can just say something simple like that. You can use the symbols if you want, if you're kind of lazy like me and most math people, but if you want to make sure that you're getting those points, you can just write from positive to negative. Or you can say it changes sign. That's actually enough. You don't even have to indicate that it's positive to negative. Positive to negative is, you don't get extra credit, you don't get brownie points. It's just really solidifying the fact that you understand what determines a change in direction. So it's kind of just like reinforcement for your answer. It's not required. And then we also have t equals, let's see, this was 3.1776, okay? Really simple to just copy and paste. If you were doing, the test on paper, you'd be looking at the screen and just writing it down. It's always a good idea to round as much as Desmos gives you. Generally, 3 decimal spaces is fine. I wouldn't suggest less than 3 decimals. I just wouldn't, unless it's how it comes out. But if there's 3 or more decimals, I would just include them, pretty much all of them. It takes 3 extra seconds to write it out. Because v of t changes sign. Oh, and actually, I was talking about, it really reinforces that you understand the change in direction. It's negative to positive here. Yeah, let me just double check that. Yeah, it goes negative to positive, and then it goes positive to negative. Silly. All right. Cool. That does it. That is totally justified. It asks to justify, so we have this extra little stuff. And I think it's fine to justify up to that point. This is a little extra. That's all. Okay, part C. Is the speed... It's kind of just like an is question. Is it increasing or decreasing at time t equals 4? Give a reason for your answer. Again, this is a great time to use calc or math understanding of what speed is represented by. Speed, again, is represented by the absolute value of the velocity. So we just want to know if that is going up or if that is going down. That's it. At t equals 4. So you can simply graph the absolute value. If you didn't have that little trick and you just have the graph of the velocity, you could also determine this by whether or not it's going closer to 0 or away from 0. So let's analyze it in that sense. At t equals 4, the velocity is already very negative. Look at how negative the velocity is. At t equals 4, that's like all the way down here. That's very negative. And it's going away from the x-axis, so it's getting more negative, which means the particle is going backwards already, and it's starting to go backwards faster. Okay? So that tells us that the speed is increasing. But a really easy way to just see that is if you simply graph the absolute value, you just have to look at whether it's going up or down towards the 0. Same concept. Same concept. And here we have that it's like clearly going away. Right? So we can justifiably say speed increasing because the absolute value of the velocity is going up at t equals 4. Now, if you're doing a problem by hand, sometimes what you'll do is you'll try to find the acceleration and you'll compare the velocity to the acceleration. And if they're opposing, if velocity and acceleration act in opposing directions, particle is slowing down. If velocity, oops, I can spell, I swear, acceleration act in the same direction, particle is speeding up. This would allow us to, answer that question more precisely if we had to do something without a calculator, and they wouldn't give you as gnarly of a graph or function. Or maybe they would, yeah, and you'd have to just figure it out. But since we have a graph, we can simply use the graph of the absolute value, and that'll work. Okay, so pretty quick problem. I think you understand that if you know how to use Desmos on a problem like this, you can work through this super fast, like incredibly quickly. You just have to make sure things are typed in correctly, that the function is represented properly. Otherwise, you're going to get values that are off. Okay. Well, that's enough blab out of me. I'll see you guys next time.